Hello guys and welcome back to another video. Today we're going to be talking about something really important and that is called Perlin noise, right? Um, Again, we're going to be using processing because we can see it visually. So let's get started. Perlin noise is an algorithm which basically allows for random terrain generation. This is what Minecraft uses actually as its terrain generation. Um, Perlin noise at its core is quite simple. It's an algorithm which is based off of the random function, and that makes the whole generation smoother and much more realistic. So let's say you're going up a hill, right? You would expect a smooth increase and then decrease in altitude. You wouldn't expect something insanely weird and random heights, right? If we were to just loop the random command over and over again and draw, for example, a terrain generation with the random, it won't look very genuine or authentic, and it will just be random points with different altitudes on a plane, right? But with Perlin noise, we can make the whole thing very smooth and make it look as if you were going up a hill. This is what Minecraft uses again to connect those blocks in a correct pattern. So, first of all, just to show the difference between the random function and Perlin noise, I'm going to first create a code that uses solely the random function. And I'll be doing something very special today. I will be using a circle to represent our Perlin noise instead of an actual sort of plane generation. And because the circle, you can see um, the difference between how smooth the changes are. So let's really quickly do size, let's say 300, 300, and then draw. All I'm going to do is to draw. So yeah, we need background. Let's do 0, and then fill. Let's do 255, and then we can draw a circle that is centered in the screen, right? And then we can use the random command, and then let's say random, and then we'll do height, which is 300. So we'll just do 300 because that's our height, and we want the format to be correct. And we'll run that. As you can see, we have this huge, well, epilepsy warning here, but we have this very seizure-like circle. And just to slow it down a bit, I'll put a delay command in here so that you can actually see what is going on. And as you can see, this is definitely not Perlin noise. Again, I'm using a circle because it can really show what this Perlin noise algorithm does, right? Now, as the circle gets bigger and smaller, that's basically simulating the terrain generation. As it gets bigger, the altitude of the terrain goes higher, and as it gets smaller, the terrain gets lower, right? This is just a symbolization of terrain generation, right? But as you can see, the circle, it's moving in and bulging out and contracting in all these different random sizes. And this is bad because let's say you were using this, just a random command, then you would have a terrain full of bumps and mountains that wouldn't really seem real, right? So what we can do is that we can actually make the circle bulge out and contract smoother by using a Perlin noise function. So we can get rid of this. Actually, we won't get rid of it. Let's just comment this out really quick. There we go. So now let's begin on the actual Perlin noise. So actual Perlin noise. So first we need two variables. We need two floats. We need first of all time equals 0.0, and that is because we just need a variable to count how much time has passed, and therefore what to do on the next step of terrain generation. Then we have float inc, which stands for increment, and basically this will be the terrain generation itself and deciding how large or how small the circle is going to be. Then we'll do some basic void setup, and there's only one line of code here, and that's size. We'll use 300 by 300 again, and void draw, which again, this is where the algorithm begins, right? First of all, we just need background. Let's say 102 because we need, again, the screen to refresh. Then we can have a float. Then we can call this change. We call this change because this will actually be how large the circle is getting, right? And this is where the main algorithm is. So first of all, we need a processing command called noise. Basically, noise will decide the Perlin generation for us. We don't actually need to do all that big code of the function of Perlin generation, but the still algorithm is still going to create a Perlin generation noise, right? So we're just doing height again because we don't want the circle to go out of the screen. We want it to stay in the screen, so that's why we're using height. We can also use 300 because that is the height, right? Basically, this will decide your change. So we have noise, which is a simplified version of Perlin noise in processing, and we have time, which is going to define how the circle is going to get larger or smaller, right? So for example, at time 1, your circle has a size of x, right? Then at time 1.1, you you don't want your circle to be size, x minus 100. You want your circle just be a little smaller, like x minus 1 or x minus 2. So noise will help us decide that for us. We put a semicolon back here. Then we take the time again. And then plus equals in inc, which stands for, again, in increment. I almost typed increment there. But basically, this is our time counter as the circle grows or gets smaller. So every time the circle grows or gets smaller, time will pass, and that's pretty logical. Then we do a quick fill here. We'll just do a nice little blue color because I was testing this beforehand, and I just like this color. Then we will center a circle, and then the variable change as its radius so that the circle will get bigger or smaller, right? And if we run this, we see that this is a very smooth generation, not like this code, which was basically generating random sizes. This actually has a pattern to it, right? So, if the circle is this big, it won't go insanely small. It might bulge out a bit more or come in a bit more. This is how terrain generation works, and this is how Perlin noise works. It basically creates a harmonious effect. That's what the definition says, but simplified, it just creates a smoother landscape to look at and something that's more authentic if you're ever playing Minecraft or something like that. So thank you for watching. I hope you enjoyed and learned something. Let's try to get to 50 subscribers. Please leave a like and subscribe. And thank you for watching, and have a good day, everyone.